Hello there, welcome to this video on polymers. Now, what does polymer mean? Well, if we take this word apart, poly means lots of, and mer means bit. So polymer literally means lots of bits. Now, one bit is called a monomer, two is called a dimer, and any more than that we call a polymer. Okay, monomer, dimer, and more than that, polymer, meaning lots of bits. And making polymers from monomers is called polymerization. And this is how materials like plastics are made. Here are some more monomers. Put the word poly at the beginning of them and you might start to recognize some of these materials. So here we've got polyethylene or polythene. We've got polyvinyl chloride, PVC. And we've got polystyrene. So even if you've never heard of some of these polymers before, if you've never heard of ethene or vinyl chloride or monomers or anything like this, you do recognize some of these substances. These monomers are all alkenes, and because alkenes have got a double bond, we say they are unsaturated. Alkanes, on the other hand, contain only single bonds, no double bonds at all, and because of that, because it's got no double bonds, we say they're saturated. I should say at this point that all of these molecules that only contain hydrogen and carbon atoms are known as hydrocarbons. If you were to put a single oxygen in there or a chlorine in there, you wouldn't call it a hydrocarbon, okay? So hydrocarbons are molecules that only contain hydrogen and carbon. Now the test for alkenes, you need to know this. The test for an alkene involves exposing it to something called bromine water. Now in this picture you can see that that double bond is broken and the bromine atoms from the bromine water join with the alkene. This turns bromine water clear. Because alkanes don't have this double bond to start with, they can't form the bond with the bromine and the solution stays orangey brown colour. Okay, so the take home point from this slide is the test for alkenes is, do they decolorize bromine water? If the bromine water goes clear, then that is, you've got yourself an alkene on your hands. Now I mentioned polymerization earlier on. This is what happens when you join lots of ethene molecules together. Now rather than drawing this long chain, and this is quite a common exam question actually, they'll give you some monomers and ask you to draw the polymer out of it. You don't have to draw this really long molecule. What you can do is you can represent a polymer like this. Okay, so here all you do is you draw the individual monomer unit and you put brackets around it and you put the N in. And the N is basically just how many of these monomer units do you need to use. Okay, so that's a much easier way of doing it without drawing that long chain hydrocarbon. So here are some of the different kinds of polymers. A very common exam question again is to ask what properties a polymer will need. So for a raincoat, for example, what properties would you need for a raincoat? You would say waterproof, non-toxic, flexible and lightweight. For a packing material, you would say it has to be light, it has to be soft, it has to be non-toxic. So that's something that often comes up. Here's a use, what properties are they? Or they'll give you the properties and ask you for an example of a use for it. Let's look a little bit closer at one particular kind of material that uses polymers, and that's Gore-Tex. Now the durable water repellent, or DWR, is a layer of expanded hydrophobic polymer. Now hydrophobic, hydro means water, and phobic, you could probably guess, means a fear of or a hate of. So hydrophobic means water hating. So what happens is when water lands on this surface, it just runs straight off. And this helps that material become water repellent, water resistant. 1 square inch of Gore-Tex material contains 9 billion pores. 9 billion. Now this means that each little pore, each little hole, is 20,000 times smaller than a water droplet. So a water droplet cannot get through these tiny little holes. So this also adds to the water resistant nature of it. But even though they're that small, they're still 700 times larger than a water molecule. So I'm talking about vapor, I'm talking about steam, sweat that's in the water vapor form. So the water molecules can leave through these tiny pores, but the very large drops could never get through in. So this makes Gore-Tex breathable and waterproof. Let's finish up by looking at a potential exam question, one of these horrible 6-mark questions. What properties should a polymer-based plastic shopping bag have? Discuss the environmental and economic impacts of disposing of these bags. 6 marks. Right, let's break this question down, shall we? First part, properties. Properties of a shopping bag. Well, one, you want it to be flexible. You're going to put different loads in this bag. It has to be able to change shape to accommodate these different loads. You wouldn't want a rigid shopping bag. Next one, strong, obviously, so the bag can hold your shopping without spilling out onto the car park floor. It's got to be non-toxic. It's got to be safe for human contact. And it would be very helpful if this stuff was biodegradable, so the bag could break down. And if it can break down, it means that we don't need so much landfill sites, we don't need to burn it, we've got less of a waste issue. So there you go, that's the first part of that question dealt with, the properties of the polymer-based plastic shopping bag. Next part, it says discuss the environmental impacts. Okay, what's the environmental impacts of throwing your shopping bags away? Well, if we haven't got biodegradable shopping bags, then we're going to have more and more landfill sites. A landfill site is when someone comes along, a company comes along, they dig up an environment, a forest, grassland, whatever. They dig an enormous hole in the ground and you throw all your rubbish in it. Then you basically turf it over and you put grass on top. More landfill sites is going to mean we get a loss of biodiversity. We're going to get a build-up of carbon dioxide and methane gases. Now, these things are both pretty potent greenhouse gases, and that contributes to global warming. Burning this stuff, burning waste, is going to release toxic gases into the atmosphere, which could also contribute to global warming. Burning plastic is a really bad idea. You get some very toxic fumes from that. So these are some of the environmental problems. Nearly there. The next part says, what are the economic issues, economic impacts? To do with money. So, now plastic bags are made from the hydrocarbons of crude oil, and crude oil is a finite resource. That means it's running out. Throwing plastic bags away is throwing away a valuable natural resource, one that we should keep or reuse or something like that. So we're throwing away a really valuable natural resource. That's not a good idea economically. Instead of having landfill sites, you could build houses on it and sell them. These could be worth a lot of money. It would create jobs and all sorts. However, if we're going to be eco-friendly and start recycling, setting up these recycling programs could be very expensive. So there's some issues to do with the sort of economic impacts of getting rid of recycling and landfill. So there you are. We've talked about the properties of plastic bags, we've discussed some of the environmental impacts, and now we've talked about some of the economic impacts. You put that together in a couple of well-written sentences, well-written paragraphs, and you've got yourself 6 marks out of 6 and a really good grade. Okay, that was very quick. I could probably spend 20 or 30 minutes talking about polymers, but I want to keep these videos short. So there you are. Hopefully that was helpful to you. Thank you very much for watching.